Hello again, Algebra 2 class. The topic of this video series is going to be inverse functions, which is Chapter 4, Section 2 in your Algebra 2 textbook. We have three main objectives in this section. The first one is to graph the inverses of functions. The second one is going to be to find inverses of functions algebraically. And the third is going to be to use inverses of functions to solve application problems. Now, before we jump into this section, I just kind of want to provide the motivation for why we even look at inverse functions here. You remember in Chapter 4, Section 1, which is on exponentials, we mentioned that we don't yet have the tools to solve for an unknown variable if it's in an exponent. Well, Chapter 4, Section 3 gives us that tool by giving us the inverse function of exponentials, which is called the logarithm. But before we get to that, we're going to look at, well, what is an inverse function in general, and talk about some easier examples to understand than logarithms. So in this first video, we're going to introduce what is an inverse function, and then we'll look at a couple graphing things. So first, an inverse function is just a function that undoes what another function does. So a little notation for you here. If we have a function, f of x, then we write its inverse function like this, f inverse of x. Now I know that little -1 looks like an exponent. That is not an exponent. It's just the notation that mathematicians use to show that this is an inverse function. So really quick, super simple example of that. Let's say we had a function f of x equals 3x. Right? So this is a function that takes an input x and multiplies it by 3 to get an output. We could say that the inverse function of f would be x divided by 3, because dividing by 3 undoes multiplying by 3. Right? Pretty much these functions are exact opposites of each other. Now, one thing we want to be able to do with inverse functions is talk about their graphs. So in this case, we don't have an algebraic representation for f of x. What we have is this table of values. So we have some x coordinates and their paired y coordinates. Now, inverse functions, if we have a table of values, are pretty easy to find because we know that an inverse function undoes whatever the original function does. So if f of x takes 0 and turns it into 0.5, then that means that f inverse of x takes 0.5 and turns it into 0. And we can do a similar process. F of x turns 1 into 1. Well, that means that f inverse of x must also turn 1 into 1. And we can keep running through the rest of the table, just switching the inputs and outputs. So 3 became 4 over there, which means that 4 must become 3 over here. 4 became 8, so over here 8 must become 4. And at this point, it's pretty straightforward to graph both of these. So we'll graph f of x first. We have 0, 0.5. We have 1, 1. We have 2, 2. 3, 4. And 4, 8, which is a little bit off the graph there. And then for f inverse, we have 0.5, 0, which is right here. 1, 1 again. 2, 2 again. 4, 3 this time, which is over here. And then 8, 4, which is again just a little bit off of our graph right here. I probably should have done this earlier, but now let's kind of draw in the curve connecting these. Let's see if I can get a good curve. That was okay. And we'll go back and do the same thing for f of x as well. So there are two functions, right? F of x and its inverse. Now, there are a couple things worth pointing out here about functions and their inverses. One of those things is that f inverse of x and f of x are just reflections of each other across the dotted line you can see on the screen, y equals x. That will happen for all inverse functions, not just for this particular example. And you might kind of be able to figure out why, pretty much because whenever you end up swapping x and y, it ends up being a reflection across this line that kind of cuts your graph in half diagonally. The other thing worth mentioning about inverse functions is that they have the same domain and range as the original function, but just swapped. Now, if you remember from earlier this year, the domain of a function is the list of all its x values, and the range is the list of all its y values. So hopefully it makes sense that the domain of your original function is the same as the range of your inverse function, because all we did to find the inverse function was switch x and y. And the same thing can be said for the range of the original. The range of the original is the same as the domain of the inverse.